section 7.1, roots and radical expressions. So our objectives is to simplify nth roots. Now, in order to do this, we're going to talk about squaring a number and also taking the square root of a number are what we call inverse operations because they undo one another. So if we look at this first one that we have, 2 to the third power is equal to 2 times 2 times 2, which equals 8. So we would say in words, 2 cubed is 8. Then if we want to undo that, we would do the cubed root. So the cube root of 8 is equal to the cube root of 2 times 2 times 2, which is equal to 2. So if we have 8 to the fourth power, that means we would have 4 8s being multiplied, which is 4,096. And if we take the fourth root of 8, or the fourth root of 496, we know that it's going to be equal to 8. So why don't you guys pause the video and see if you can fill out the next ones. So 7 to the fifth power would be equal to 16,807 here. 3 to the sixth power is equal to 729. And this says a to the nth power is b, so a to the nth power equals b. So now if we want to do the inverse or the opposite of that, we would say that the fifth root of 16,807 is equal to, I know, 7. The sixth root of 729 is equal to 3, and this says the nth root of b would then be equal to a. And so there's some things we have to talk about that. Now you can also kind of check this using your calculator. So if I want to check with my calculator, I can see 7 to the fifth power is equal to 16,807. So now the way that you would do the fifth root of this is you would do the number 16,807, and if you go to math, oh, I guess we have to put it in first, so let me do that again. Go back to my home screen. So you want to do the root first, which is 5, and then go to math and number 5. So the fifth root of 16,807 we know is going to give me an answer of 7. So that's the way that you can use your calculator to check your answers. Now just to take a look at this n right here is what we call our index, and this a is the radicand, which is written right here. And then we just call the radical sign a root. Now, when a number has two real roots, the positive root is called the principal root, and the radical sign indicates the principal root. So this would be the opposite with the negative in front of the principal root, and this would be both roots, the plus or minus. So you could easily do these on your calculator, or hopefully now you know what the square root of 64 is. So the square root of 64 would be equal to 8. So that would be the principal root. This would be the opposite of the principal root for the next answer because that negative is in front. So this would be negative 8. This would be plus or minus 8 for our solution. Over here, now we have the cube root of negative 27. So again, if you don't know how to do that, you can do it in your calculator. So you would hit 3, go to math, and then number 5, and then negative 27. And notice we get, in this case, negative 3. And then for the last one, you could do that in your calculator as well, or you can ask yourself, what times what 4 times would give me 16? And I know in this case, it would be negative 2. Now for this, if I do another problem, which is on your page, if you have the square root of negative 64, the square root of negative 64 would be no solution, because we cannot take the square root of a negative number. However, over here, if you have an odd power, you can have a negative underneath, because I know that negative 3 times negative 3 would be positive 9, and positive 9 times another negative 3 would give me negative 27, whereas there's no number multiplied by, 8 times negative 8 would work, but that's not going to give you a perfect square, so you can't use it. And even if you try to do this in your calculator, if you do the square root of negative 64, it would say error, non-real answer. So that's another way you can also look at that. Then also on your paper, which I don't have here, so we'll just put a new page in real quick, it says, find all the real cube roots of 216. So if I want to find all the real cube roots of 216, all I have to do is take the cube root of 216, and that would be equal to a value of 6. For the next one, it says find all the real square roots of 400. The key words are find all the real square roots of 400, so that would be plus or minus. I'm going to have two answers in this case, the square root of 400, which is equal to plus or minus 20. And the way I can look at that is because I know that 20 squared is equal to 400, and also negative 20 squared is equal to 400. So that's why both the plus or minus are needed for our answer when it's an even index. When it's an odd index, you're going to only have one answer because I know that 6 times 6 times 6 is 216. If it was negative, then I would get a negative 216. So if I wanted to find all the odd roots of negative 216, my answer would be negative and 6 instead. So odd answer is one answer. Even, we're going to have, when you have even index, which in this case, remember, when the index is not written right there, that means you really have an index of 2. So since the index is 2 is even, you're going to have those two different solutions. Let's go back here. Okay, so let's go to the table that we have on our other page. So for this, the table shows the number of solutions when you're solving equations in the form of a to the nth equals b. So you're solving for a in this case. Now, if your b value is going to be a value greater than 0, then you're going to have two solutions. If it's even, and if it's odd, you're going to have one solution. And this is already written on your page. So if it's 0, you're going to have one solution. One solution. If b is less than 0, then you have no solutions if it's even index. And this would be one solution, because we're allowed to have negatives underneath the radical. So for example, on your page, it says we want to solve a squared equals 64. And we're solving for a. So remember, I want to do the opposite to solve. So a squared equals 64. That means a is going to be equal to the square root of 64. And remember, when we have we're finding all the roots of this, I can have the plus or minus my answer, which would be equal to plus or minus 8, because 8 squared is 64 and negative 8 squared is 64. Now over here it says we want to solve a cubed equals 125. For this one, if I take the cube root of 125, so a is equal to the cube root of 125, that's how I solve, which is equal to 5. Now, I can't have negative 5 as my answer because negative 5 times negative 5 would be positive 25, and 25 times negative 5 would give me a to the third power equals negative 125. So if instead that was a to the third power equals negative 125, my answer would be negative 5. So if I have a squared is equal to, in this case, 0, well, the square root of 0 is just 0, so you have one solution. Same thing if it's odd. If I have a to the third power equals 0 here, again, the cube root of 0 is also going to be equal to 0. So one solution, plus or minus wouldn't change that. And then for this next one, we have a squared equals negative 64. So when you solve using your square root, a is equal to the square root of negative 64. Remember, we said we can't take the square root of a negative number, which is what this says right here. So that means there's no solutions. But we can take the odd root of a negative number. So in this case, I have a is equal to the cube root of negative 125, which is going to be equal to negative 5. And again, you can use your calculator to find that. What I suggest doing is memorizing the first first 25 perfect squares. So what are perfect squares? Like 4 is a perfect square because the square root of 4 gives you 2. We know that 25 would be a perfect squared because the square root of 25 is 5, and the square root of 9 would be a perfect squared because the square root of 9 is 3, and so on and so forth. I would also memorize the first 6 perfect cubes, and that will help make these problems a little bit easier when you're working them out. All right, so we're going to solve these examples. So we're solving for the variable, and so the first one we're going to solve for a. So a squared equals 25. So since the index is 2, that means a is going to be equal to the square root of 25. We don't write that 2 for the index when it's square root. So the square root of 25 we know is equal to plus or minus 5, and again, don't forget to write that plus or minus in front because you can have both the positive or the negative answer. For 36, again, since it's an even power and you're going to take the square root of both sides to get rid of that power, that means that the square root x is equal to plus or minus the square root of 36, and I know that's a perfect square, so x is equal to plus or minus 6. And then for the next one, the cube root, since it's an odd power, you only have one solution all the time. So then m would be equal to the cube root of 8, which is equal to 2, because 2 times 2 times 2 is 8. Now, the next part we want to talk about is we're going to simplify the following radicals. So when you're simplifying radicals, you want to circle your answers according to the index. So you want to find groups according to the index. So the first one, it's the index of 2, so that means I want to look for groups of 2 or perfect squares. So in this case, I know that I'm going to break down 4. 4 is the same thing as 2 times 2, so that's one group of 2, so that's going to go on the outside of my radical. And x to the 6 is x times x times x 6 times. So if I look at this, I have a group of 2 here, and then I have a group of 2, one group of 2, another group of 2. So that means that the square root of 4 times x to the 6 would simplify into you take out one of your 2's, and then you're also going to take out 1, 2, 3 x's. So this right here would be your solution. Another way to look at that is you look for your perfect square. So 4, we know is square root of 2, or the square root of 4 is 2. And if you take your index, which is 2, and divide that by this number here, so 6 divided by 2 is 3, so that means x to the third goes on the outside. So let's look at the next one. So we have an index of 3, so we're looking for groups of 3 that we can take out. So what I do is just divide my powers by the index. So 3 divided by 3 would be 1, so this is going to be a to the first power, which you don't need to write the 1. And then 6 divided by 3 is 2, so a b to the second power, and that would be my answer. Or if you wanted to, you could write it out. So a times a would be one group of 3, and then the b's, notice that we have 2 groups, so 2 go on the outside for the B's and 1A goes on the outside. So that's how you split it up, just like when you think about the 25, the square root of that, it's 5 times 5, so we only take out the 1, not both of them. So for the next one, your index here is 4, so now I'm looking for groups of 4 to take out. So take the power, 4 divided by 4, I get 1, so x to the first. And then here, I would get 9 divided by 4. So that means I want to figure out how many times does 4 go into 9 evenly. It goes 8 times, or twice, because 4 times 2 is 8. So I know that y to the second power would go on the outside, but I have some left over. How many do I have left over? This would be the fourth root of y, because 4 times 2 is 8, and 1 more would give me 9, so I have to keep that 1 more underneath that fourth root that I have there. So that would be my solution for this one. If I look at the next one, I have the square root of x plus 1 to the fourth power. So in this case, my index, when it's not written, is 2. So 2 divided by my power here, which is 4, gives me, or 4 divided by 2 gives me 2. So this would be x plus 1 squared. And then, of course, remember x plus 1 squared. I can leave my answer like this, or if we're simplifying, usually you don't want parentheses. So remember that's really x plus 1 times x plus 1, and you would have to FOIL or box that out. So x squared plus 2x plus 1 would be my solution. If you leave it with the squared right now, that's okay. So now I'm going to do the next one. What happens when I don't have a number with a perfect square or cube or whatever I'm working with? I'm going to want to break it down with a factor tree using prime numbers and then see how many groups I can take out. So, and there's many different ways that you can do this. I'm going to do just the one. So if I look here, I have the, let's do this on the other page. So I have the square root of 460, x to the third, y to the fourth. So for this, I would break this up. So let's say we want to do 46 and 10. And again, you don't have to break it up this way. You'll get the same answer in the end. So I know 46 breaks up to 2 and 23. 2 is a prime number. 23 is a prime number, so I can't break it down anymore. And then this is going to break down into 5 times 2, and both of those are prime numbers. So I'm looking for groups of 2 since my index is 2. So this and this would make one group of 2, so that means I put a 2 on the outside. Now 23 and 5, there's no groups of 2 and they don't break down, so that means 23 times 5 stays underneath my radical. Before I do that, then I'm going to go ahead and simplify my variables. So I have x to the third. So my index is 2, so 3 divided by 2, so how many times does it go in evenly? Once, with 1 left over. So this would be x. And then y, 4 divided by 2 would give me 2. So what's left underneath the radical? 5 times 23. And then we also have an x left over, so I just have to multiply that 5 times the 23. So 2xy squared roots 115x would be my solution. Now again, you didn't have to break down 460 like that, but I just find it easier. Oops. So then going back to our page. So we just said that this one was 2xy squared, the square root of 115x. Now let's look at number 6 together. Number 6, we have the sixth root, so we're looking for groups of 6. Now, before I do anything, I would try it on my calculator first to see if I can do the sixth root of 64, because that's going to make my life a whole lot easier. So the sixth root, so 6 math, number 5 of 64 gives me a nice number with no decimals. So since it gives me a nice number with no decimals, I know that 2 is the sixth root of 64, so I'm going to use that. I could make a factor tree if I wanted to as well to break it down, and I would see I would have one group of 6 2s. So then c to the 6 would be 6 divided by 6, so 1 c goes on the outside. And notice that we have a to the 5th. There's no group of 6, and you can't ever make one, so that stays underneath the radical. And don't forget to write your index. So a lot of students forget to put that index when they write this. So then that would be your solution. So if we look at number 7, I'm going to do the same thing. Now, if I don't know what the fifth root of 32 is, which in this case it's 2, I could again make a factor tree if I wanted to and break it down. And then you would see you would have a group of 5 2s. Or I'm just going to put that down here. So then x to the 10th, so 10 divided by 5 is 2, so that becomes x squared. And 15 divided by 5 is 3, so y to the third. And in this time, we have nothing left over, so that would be my solution. Now, if you look at number 8, we have a negative underneath the radical, but it's an odd index, so remember, that's okay. That means my answer is going to be negative. So I know that negative 8 to the third, or the cube root of negative 8 is going to be 2 to the negative 2 to the third power. So this gives me negative 2. And notice that my index is larger than the powers that I have. Therefore, I cannot take out any of those variables. So they would stay underneath the cube root. Now I would pause the video and see if you can solve number 9 and 10 on your own. So for number 9, again, we're looking for things that make a group of 3. So 27 is the same thing as 3 times 3 times 3, or you can do it in your calculator. So that's the 3 on the outside. C to the 9th power means we have C to the 9 divided by 3 is 3, and then that's a 15 right there. So 15 divided by 3 would be y to the 5th power. And then 160, if I try to take the square root of it, even if you look on your calculator, you would notice that the square root of 160 is not a perfect square. It gives me a decimal, so that means I'm going to have to make my factor tree. So when I make my factor tree, I'm going to do 10 times 16, which those are not primes, so I can break them down more. 10 breaks down into 2 times 5. And I already know 16, the square root of it is 4, so I can put that on the outside, or I can, if I want to, break it down more. So that's 2 times 4, and then, or 2 times 4, 2 times 8. And then 8 breaks down into 2 times 4, and 4 breaks down into 2 times 2. So I'm looking for groups of 2. I have 2 here and here, so that would go on the outside. So 2 times 2 gives me 4 on the outside, or the square root of 16 is 4. Then that means underneath my square root, I have left these numbers here, which I have to multiply back together. So 2 and 5 are left, so that's 10. That did not come out. And then we have c to the 3rd power, so that means I can take out 1c here, and then 1 would be left over here. And then we have y to the 14th, so that becomes y to the 7th. None are left over underneath, and z1 would be here, and I would have 2 here, because 2 times 2 is 4 with 1 left over, and that would be my answer. So that's 4c y to the 7th z squared, and then the square root of 10cz. Now for the next one, it says, find the real number solutions of each equation. So that's what we did before. So I'm solving this first equation for p, and since it's an even power, that means I'm going to have 2 answers, plus or minus. So p is equal to plus or minus the square root of 100, which is a perfect square, so plus or minus 10. So why don't you pause it and see if you can do these others. It shouldn't take you very long, hopefully. So for this one, you would get w is equal to plus or minus the square root of 144. Which is plus or minus 12. For the next one, you would get, notice it's a 4th root, not a square root, so be careful. So you have the 4th root plus or minus the 4th root of 81, which is equal to plus or minus 3. And then this next one, we're solving for an odd power. So remember, odd powers, when you solve, only have one solution. So this would be x is equal to the cube root of 216, which we already know is equal to a value of 6. And you can always check your answer. 6 to the 3rd power is 216. Excuse me. So for these next ones, you're just evaluating using your calculator, and you're going to round to 3 places. So you can just go ahead and use your key that I showed you. So the square root of 122 would be equal to 11.045, and that's what I would write down. And then why don't you guys finish the rest of those on your own?